This is just going to be a quick review of right triangle. Oh, I left the N out of triangle. I did that twice today. Right triangle trigonometry that you learned in geometry class last year. So we're just going to go through a couple of examples. But first, most important thing, on your graphing calculators, before you even start, we're going to be working in degrees. So you have to go to mode, and then just like we did when we were graphing, you have to be sure that you're in the right units. So we're in degrees when we're doing these problems. So make sure that you change it to degrees, and then you can quit out of there. All right, so here's our first example, and this is an example when you're finding a missing side of a right triangle. So the first thing you want to do is everything is in relation to the angle that you are given. So you label your sides. This is the opposite. This is the hypotenuse. So we're not using the adjacent. So then you think of your SOHCAHTOA. If we're using opposite and hypotenuse, that's sine. Now some of you may have been taught differently, but this is how I tend to teach solving these. You're going to set up a proportion. The trig function is always with the angle. So that's sine of 55 degrees. And then over here, you do what your trig function says. So sine is opposite over hypotenuse. So that's 7 over x. And when I was first learning to do this, I always struggled to figure out what I needed to multiply and what I needed to divide. But remember, we can always put 1 under anything, and it won't change it. So if we just set that up as a proportion where your trig function is over 1, then you can just cross multiply. So I just have 7 times 1 equals x sine of 55. And then I divide by my sine of 55. Type that in your calculator. So I have 7 times 1 divided by the sine of 55. And that gives me 8.54. So that means that side x is approximately 8.54. Kind of just little things to double check yourself. The sine across, or the side across from the right angle, the hypotenuse, should always be the biggest side on your triangle. So if you've gotten 6 or something here, that obviously can't be right. So just kind of something to double check as you're going along. Okay, second thing we have to be able to do is find an angle. So we start the process the same way. Everything is in relation to the angle that's involved in the problem. So this is my opposite, this is my adjacent. Go back to your SOHCAHTOA, it's tangent that involves opposite and adjacent. Set up your proportion, tangent of your angle, which in this case is our x, equals opposite over adjacent, so 11 over 9. Put your 1 underneath there. So we have 9 tangent of x equals 11 times 1, which is still 11. Divide by your 9, so 11 divided by 9 is going to give us approximately 1.22, but it's 1.2 repeating. So here's a hint. Once you type that in your calculator, leave it in there, okay? I've left that whole decimal in our calculator. We do not want to round until the very end. So now we have that the tangent of x equals 1.222, but that's not what we want to know. We want to know what x equals. So in order to get rid of tangent, you're going to do the inverse tangent. So on your calculator, that's your second tangent button. So you do second tangent, and then to bring that whole decimal back down, you do your second negative button, and it should pop up ANS, which means it's bringing the answer from the previous step down. So that's 50.71. So again, you don't want to round until the very last step. Okay, that's all there is to it. Hopefully you're ready to go.